I am often asked about how to go about creating a correlation curve for a Schmidt hammer. This presentation explains a reliable method, and the same procedure can also be used to create a correlation curve to ultrasonic pulse velocity. So why do it? NDT methods like the rebound hammer and ultrasonic pulse velocity do not measure compressive strength. In order to estimate the strength, a correlation is required. The accuracy of the estimation depends on how well this correlation curve is determined. Every concrete mix has its own correlation curve. There is no such thing as one curve fits all. And for this reason, the use of manufacturers' correlation curves is not allowed in major standards. It is necessary to develop a specific relationship between the NDT test and the compressive strength. This procedure calibrates your instrument to the specific concrete you are testing, and it provides the most reliable and the most accurate results. So what are some typical applications? Well, it is often used on large projects to determine the optimum time for formwork removal. It's also used by precast element manufacturers, both for quality control and also to determine when it is safe to transport the elements or for formwork removal. And of course, it can be used on site to estimate the strength at different locations in the structure using the same concrete mix. This presentation deals with creating a correlation to standard cubes. The European standard EN 13791 provides the process using cores, and it's a method that's also recognized by ASTM. For more information on that, please visit the Screening Eagle Technologies YouTube channel. So the process using standard test specimens looks like this. First of all, we manufacture a sufficient number of test specimens. Then we test the specimens both with the NDT and the crush test at predetermined intervals during the curing process. We use the data pairs obtained to establish the relationship, and finally we program the correlation curve into your NDT instrument. The NDT instrument is now calibrated to the concrete mix. So to recap, here are the 4 steps again. Manufacture the test specimens, test the samples at predetermined intervals, create the relationship between NDT results and compressive strength, program the custom curve into your NDT instrument. The recommendations made here are taken from the methodology used by the Federal Institute for Materials Research and Testing in Berlin during the validation of the Procex Silverschmidt hammers. So how many test specimens are sufficient? Easily said, the more specimens the better, but this is also expensive and impractical. The BAM Silverschmidt example used 33 samples for each mix, and they tested 3 samples at each test interval to ensure having a valid result. EN 13791 recommends taking a minimum of 10 cores to create the correlation. It's based on having at least 8 valid core results in the case that 2 of the cores result in an invalid crush test. So taking this as a guide, the recommendation is to have at least 8 valid results when working with test specimens. Now let's look at the test intervals. In order to have a full range of strengths, the specimens have to be tested at different intervals from the time of casting. Strength develops rapidly in early stages and slows down as it approaches the maximum strength. This is typically after 28 days. So the rate of strength development must be taken into consideration when planning the tests. Test more often in early stages, and test intervals should be adjusted to curing characteristics of the mix under test. Here we can see the test intervals from our reference example. There were 11 test dates in total, and as you can see, the tests were much more frequent during the early stages. In order to obtain consistent results, It is recommended to fix the specimen in the press before carrying out the NDT test. In the reference example, a force of 2.5 megapascals was used to pre-stress the specimens. Then you should perform the NDT test according to your regional standard. Another question I'm often asked is there enough space on a 150mm cube for a rebound hammer test? If we look at the European standard EN 12504-2, it requires a minimum of 9 impacts 25 to 50mm apart. So the smallest valid grid is only 50 by 50mm for all 9 impacts. So there's more than enough space on a cube. So on completion of the NDT test, you should proceed to perform a crush test to obtain the actual compressive strength of the specimen. Now we move on to establishing the correlation curve. The rebound value plus the crush test result provides one data pair for the correlation, as you can see here. Once all samples have been tested, we have a complete data set. Here you can see 11 of the test results taken from our reference example. In order to obtain the correlation curve using Excel, we right-click on one of the data points and then add trend line. The trend line function creates a best fit curve for the data set. Depending on the range of strengths, either linear or exponential is recommended. Select Display Equation on Chart to show the correlation curve, and select the R-squared value on the chart to show how good the correlation is. This may also be used to help selecting the best curve. A higher R-squared value indicates a better fit. And that's it. The correlation curve has now been created. Y is the compressive strength, X is the rebound value. The final step is to program this curve into our Schmidt hammer. This can be done using the custom materials function in the Schmidt app. The Schmidt hammer has now been effectively calibrated to this specific concrete mix and will give the most accurate estimates. One thing to bear in mind when using this type of correlation for estimating in-situ strength. The in-situ strength is generally less than that measured on standard specimens, so a correction factor is normally applied to accommodate this difference. The EN standards typically apply a factor of 0.85. As a final remark, I'd like to point out that the Screening Eagle Technologies YouTube channel provides a complete set of presentations on this topic. So if you are interested in compressive strength estimation, I would highly recommend visiting this YouTube channel. Thank you very much for your attention.